Hi, Kate. Hi, Mike. Thanks for showing up, and hopefully we'll get a couple others. I did get an email from Pooja that she's having some tech problems, so we'll see if she can make it. Let me tell you the plan today. Today we're going to be doing two things. We're going to be looking at chapter 12. I'm sorry, chapter 10, which is the chapter on the difference between two means and the difference between two proportions. So it turns out that's a really important, useful thing to know how to do. In chapter 9, we learned about hypothesis testing, but all we did is had a single mean or a single proportion. But in the real world, usually you're comparing. Usually you're saying this one's better than this one, or things have changed since last year. That's more common than just having a single mean or a single proportion. So we'll look at that. It's not that long a chapter. This week, I try to make it light in terms of new material to do, because I know you're probably a bit tired right now because you took the midterm. So after talking about chapter 10, then it's time to start thinking about the project 2. So I'm going to really get into the project 2 and what types of things you have to do to succeed on project 2. So, we lost Kate, it looks like, but thanks for coming. So that is the plan. I want to mention one thing is that I now have the exams. I think I have one more to come in, actually. So I have one more to come in, but they have to be taken by today. So what I do is I collect them all today, and then tomorrow I'll grade them. So I should be able to finish by the end of the day tomorrow. You can look to see how you did. I grade one problem at a time and then post them all at once. So you should be able to see how you did on the midterm by the end of the day tomorrow. Maybe early, we'll see. But that's when I'll start. I'll start in the morning and then hopefully finish by late afternoon is my plan. So are there any questions about anything, Mike or Caledon? Any questions? Again, this is a good time to ask. Okay, no questions. All right, what I always like to do, and this is one of the things I like about this class the most of any class I teach, is that I can always bring up some current event and relate it to what we're doing. So whereas I can't do that in other math classes that we have, but stats, you can always do that. So let me share my desktop. And I have a little current event, little survey. One of the big things that's been happening, big bad things that's been happening. What big bad thing has been happening recently? And a really big bad thing.
The coronavirus.
Yeah, that virus. So let's take a look. Actually, no, sorry, I didn't choose that one. Actually, I was going to choose that one, but then the numbers didn't come out as nicely as I wanted to show. All right, this is a good or bad, depending on how you feel about this one. Sorry about that. I did not mean to say this was good or bad. I thought I was going to do the virus, and then I changed my mind because the numbers were just, the p-value wasn't a good one to explain how things worked. So instead, I found another one, and this is Gallup, and it's what percentage of Americans smoke marijuana, okay? And that, not necessarily big in the news today. I'm kind of surprised that none of that's happened. They don't talk about that during the debate at all. But, you know, it's actually a big deal in terms of nationally. So here it is in a Gallup poll in 2019, 12% of US adults said they smoke marijuana, a percentage that's essentially unchanged since 2015. So what they're saying now is that marijuana use has held steady. So has it changed? So in our class, hopefully you know, when you have a question where you want to see if something has changed and you're doing a hypothesis test, then what is H1 going to contain? What's H1 going to contain when you want to find out if something has changed? That's why I chose this one, because I didn't get a good example last week of change. And now I want to do an example of change. Yeah, this is going to be a not equal to sign. So I want to grab a few numbers. And in fact, I'll just tell you because I read this article before. We don't have to read the whole article, but you can definitely see right here that in 2015, 11% of Americans said that they smoked marijuana. And 2019, which is the most recent year they got, we don't know 2020 yet. That'll probably come soon. That was 12%. So when you look at it, does it look like it's changed? Is 11% and 12%, are they the same number? What do you think? Yeah, they're not the same number, but we want it. So you might worry, well, they're saying it hasn't changed, but I see a change, 12%, 11% to 12%, that's change. So let's do this the way we're supposed to do it. Instead of just looking at these two numbers, let's run a hypothesis test. The good thing about chapter 10 is it's basically the same as chapter 9 with a couple little tweaks, as we'll see in a moment. So let me go and we got to do some writing. So what I want to do is I'm going to start out by writing down the null hypothesis and the alternative hypothesis. So first thing, hopefully you all know that when you have a null hypothesis, you write H naught. Any questions on that? Then what we're going to do is we're going to say, has it changed? Well, is this, well, I'm glad you're back, Katie. Okay, even though your session froze, you're back up, which is good. So the question is, has it changed? Okay, but what was the survey question? What do you think the survey question here was? What did Gallup ask people? And very important to be able to think about that. What was the survey question? What did they ask all of these people? Turns out this year they asked 760 people. So what was the survey question? Yeah, do you smoke marijuana? Okay, it wasn't how many people smoked weed. It was, do you smoke weed as a survey question. Does that make sense, Kate? So that's really important because if the survey question is, do you smoke marijuana? The answer is yes or no. If it was how many people, then it would be a number answer. But this is a yes, no answer. And when you have a yes, no answer, we use the letter P for proportion. And P, I'm going to write, I'm just going to use P1, which is P for 2019. And that's going to be equal to P2. And P2 will be 2015. Let me type that out actually, because that's important. So P1 is 2019. And P2 is 2015. Okay, because you always want to think about that. Okay, then we're going to have an H1. So let's do that. H1 colon P1. And I usually like to do this. So I go P1, then I write P2. It's always going to start the same. The only thing that changes is the inequality. And as Caledon said, this is a not equal to. So this is what's called a two-tailed test. Any questions on that? Okay, we also know that, or you may not know, but I read through the article, N1 was 7 to 60. And N2 was 880. So they asked more people last time. a while back. Okay, and that's in the article. All right. Now, if we want to get X1, which we're going to need for the calculator, remember that in 2019, 12% said they smoked. And if you take 12% of 760, that'll give you your X1. And that X1 is 91 is what I got when I put in my calculator. And then X2, that's going to be 11% of 880. And 11% of 880, if you put in your calculator, is 97. Any questions so far on getting all the numbers? Okay, so what we're going to do now is go to our calculator. So let me show the calculator. So it's very similar to what we've done before. We're going to go to Stat. We're going to go to Tests. That's the main thing. So what test do you think we're going to use? It's on the screen. That's a hint. Which of these do you think is going to be the right one? We got Z-test, T-test, 2-SAMP T-test, 2-SAMP Z-test, 1-prop Z-test, 2-prop Z-test. Then we got Z-interval, T-interval, etc. Yeah, this is going to be 2-prop Z-test. 2 means we had 2 samples. We had the sample from 2019, and then we had the sample from 2015. Prop means proportions. That's because in H0 and H1, we had a P1 and a P2. That stands for proportion. Z means you had a large enough sample size. So in this case, X1 was 91, X2 was 97. They're both bigger than 5. And then if you take 760 minus 91, that gives you the number of no's. That's bigger than 5. And 880 minus 97 is also bigger than 5. All of those have to be bigger than 5, and then you can use your Z-test, the 2-prop Z-test in this case. So let's go choose that one. And I hit enter. So now I just type in my values I had. I had 91 for X1, and then N1 was 760. And then X2 was 97. And N2 was 880. Okay, notice the sample sizes don't have to be the same number. That's important because otherwise you'll get confused. What does have to happen, I want to give you a warning here. X1 and X2, if you're doing the 2-prop Z-test, have to be integers. They have to be whole numbers because it doesn't make sense to have a fractional person say yes. So make sure that if you're doing this, using a calculator to find X1, you round. Okay, use the rules of rounding. Now we want to have P1 not equal to P2. So I hit enter on P1 not equal to P2. Color isn't in most calculators and we don't care about it. Any questions before I hit enter? Any questions on getting this into the calculator? Okay, let's hit enter. And this gives us everything we need. Okay, notice that P1 hat was about 12% and P2 hat, that's about 11%. That better happen because that's how we found that we got those percentages. The Z is the test statistic, and that's 0.6. And the P value is about 0.55. So now I can go back and we can start interpreting what's going on here. So notice p-value was equal to 0.55 about. So what's the conclusion? What do you think? Yeah, we fail to reject because 0.55, we don't even need to be given a level of significance. That is a huge p-value. Okay? Remember, the p-value, you only say you reject the null hypothesis if you look at the p-value, which is a probability, and say that's just too rare to happen. Well, if you have a 55% chance, right? If you do something that has a 55% chance of happening, you're not going to say, oh my God, that was strange. No, you're going to say, yeah, 55%. Well, that's pretty common. Okay, that's how p-values work. And again, 0.05 is kind of the general line that if it's less than 5% chance, you're going to say that's too rare to happen and we reject. But 55% is never going to be too rare. So what we can do is we can say there is statistically insignificant evidence to make a conclusion about whether there is a difference in the population proportion. Maybe there was, because we're talking the past, in the population proportion of Americans who smoke marijuana in 2015 and in 2019. So notice that's just a fancy way of saying we really don't know, okay? But we can say that they're not significantly different. Sometimes you say that too. Okay, are the proportions exactly the same? Probably not, but they're not significantly different. Any questions on this idea? Does this feel a lot like chapter 9, what we did last week, and you were tested on? Yeah, there's not a lot of difference between this and what we did last week. Okay, so this is a reinforcement of chapter 9. And hopefully you all really got that because that was on the test. So hopefully you got it. Again, I haven't graded the test yet, so I don't know how you did on it, but that was on the midterm, chapter 9. Okay, with chapter 9, you didn't have P1 equals P2, you had P1 equals a number, but it's not that much different. Okay, I'm not going to type it all out, but you can say basically the same thing with interpreting the p-value. You would say that if the proportion of Americans who smoked marijuana in 2015 and 2019 was the same, and if we did another study of 760 in 2019 and 880 asking them about 2015, then there would be a 55% chance that they would differ by at least 1%. Okay, that very similar to last week. And similarly for the level of significance, let's say we use a 5% level of significance, then again, you say that if the population proportion in 2015 and 2019 of those who smoked marijuana was the same, and if we did another study of 760 asking about 2019 and 880 asking about 2015, then there'd be a 5% chance that we would falsely state that there has been a difference between the two. Any questions on that? Okay, so this should be really similar. It should feel really similar. Okay, let me give you some other examples. I'd like to do at least one current event, and then I'll make up some examples that I've got, kind of made up examples. So I got to erase this. And let's pop in a new example. Actually, I think I'm going to do this because this is going to help you on the project before I pop in what I had in mind. This actually works for both chapter 9 and 10. Wait, not yet. Let's one more time. It has too many spaces. Just 1 second. For some reason it didn't do the C. Okay, so here's the next one. This is a little more idea oriented, but it's something people have trouble with. So I want to make sure that you get it. Okay, so suppose you conducted a hypothesis test for the difference between two means with a 5% level of significance. Discuss whether a new study with the same hypothesis would be recommended for each of the p-values. So let's do one at a time. If you had a p-value of 0.04, do you recommend doing a new study? What do you think? Vote yes or vote recommend or don't recommend. So what do you think? If your p-value is 0.04, would you say we need to do one more, we need to do a study with a bigger sample size? Okay. So any ideas? So Mike says don't recommend. Kalanan, what do you think? Okay, not sure. Okay, that's why I brought this up, because this is a hard one for people, but it's really important. So the idea here is if the p-value is 0.04, remember your goal when you do a hypothesis test is to have information and to be able to say, yes, I know, I can say that I have evidence to show that the alternative hypothesis is correct. So what do you think? Do you have evidence to show the alternative hypothesis is correct? That you should both know. Yeah, we definitely have evidence to show the alternative hypothesis is correct because 0.04 is less than 0.05. So the idea here is you won the game. If you win the game, you don't complain and say, well, I need to play again. Does that make sense? You celebrate. Is that totally clear? Maybe someone else might want to do a new study, but you don't do a new study because you get to publish. So for part A, the answer is no, we don't need a new study. How about part B? You need to do a new study for part B. So that's 0.06. Any thoughts? Okay. Yeah, actually, you can't say you were not wrong, but you can say you're hopeful still, right? Now you're playing a game and you lost the game, but you only lost by a tiny bit. And you still think that you're a better player. Does that make sense? Okay, now remember, what you can't do is do a new study with the same sample size. Because if you do that over and over again, eventually you'll have a type 1 error if you were wrong in the first place. Does that make sense? So it's a lot of work. You're not happy that you have to do another study because it means much, much more work because you got to like triple the sample size because you got to make sure that the law of large numbers takes place. So part B is yes, you can do another study with a much bigger sample size. How about part C? If you had 0.89 as your p-value, you didn't do another study. Yeah, in this case, it's kind of like now you're playing a game. Let's say you're playing a game of soccer, and you're behind 12-1, and in the very last 1 minute that you get fouled and the referee doesn't call it. Do you argue? Okay. The answer is no. You're down so much, it's hopeless. Does that make sense? So if you had 0.89, it's time to just say it's hopeless. I'm not going to try and do another study. That'd be a complete waste of time. A lot of work, and there's a really good chance I'm wrong anyway. Does that make sense? So you can be doing this on your project, by the way. That's why I wanted to show you this piece. Okay, now let's go back to a more of a do-it problem from chapter 10. Okay, so let's go ahead and let's do another one. Takes a minute to copy and paste it in. Okay, so here's the next question. A manager wanted to see if people spend more money in her gift shop if they are given a free piece of candy when they enter the store. Okay, you ever been to a store and they gave you like some candy or something, some little gift? Okay, maybe you never had that before. Okay, maybe not. Okay, yeah, you've had it. Yeah, Costco's one of them. Okay, that costs some money, by the way. So the question is this going to help this gift shop in terms of better sales? And like Costco, right? Costco does it because they have decided that it helps with better sales, right? But how about this lady's gift shop? Does that make sense in terms of what we want to do? Okay, so in this case, we have with candy as the first row, and then no candy is going to be the second row. So we need to do H naught and H1 again. So let's write that out. We have H naught. Okay, now, what is the survey question here? Okay, or what's the data that you're collecting? What are you going to ask the cash register, I guess you'd be asking. Any thoughts? So what's the survey question? That's like one of the things people have trouble with here on all these problems. Okay, so that's not the survey question, Mike. That's do people buy more if they get candy is not the survey question. That's the question of the study, which is different. Okay, that's more of the hypothesis. The survey question is how much money did you spend? Is that clear? So the survey question is how much money did you spend? And an answer to that, in fact, the first person's answer was $25. And that's a number. And because that's a number, our variable's mu. And I'm going to write mu c for mu and given candy equals mu n. And that means not given candy. So what's the mean amount of money people spend giving candy versus what's the mean amount of money people spend not giving candy? And H naught those means are the same. Then there's H1. Okay. And in this case, we're going to have a mu c and a mu n. We can always write those down without thinking. You just repeat it. And then what's the inequality for this particular hypothesis that we're doing? Is it less than, greater than, or not equal to? Any thoughts? So what's our inequality? Okay. You say less than, but let's look at it again. It says, do they spend more money if they're given candy? So candy's on the left. We want to find out if candy is more than not candy. Does that make sense, Mike? So you got to be very careful about these inequalities. Yes, this is a greater than, not a less than. Okay, well, we'll go back to our calculator. So let me pop up the calculator. And let's clear what we had before. And now I'm going to go to stat. And I need to enter my data in. So we've done this before. I'm going to clear out whatever I used to have. Then I'm going to clear this guy out. And then I enter L1 as the candy, 25, oops, missed, 25, and then 14. And this next person spent a lot, 260, big gift. Then 98, then 55, then 18, 29, 44, 91, 83, 17, and 32. Then I'm going to go to L2 and type in those numbers. 37, the first was 51, the next one was 40, 37, okay, 40 again, 22, 21, 9, 30, 28, 19, and 11. By the way, is the sample size large enough here? Are the sample sizes large enough?
Yes.
Okay, one more guess?
Yes.
No. No. Okay, how
Why?
many do you need to be able to do statistics when you have
30.
quantitative? Over 30. There's definitely not more than 30 numbers. Does that totally make sense? Hi, Pooja. Glad you were able to finally make it in.
Hi.
But do you see that we don't have over 30? So the only reason why I'm doing an example with such a small sample size is I don't want to waste your time with me typing in a bunch of numbers. Does that make sense? Okay, in the real world, if you were the manager of this gift shop, you would do more than 30 for your cash receipts. Is that clear? So I want to warn you that this example is not realistic because in the real world, you do over 30 so that you can actually run the statistics. Because you would have to assume it's a normal distribution, which is probably wrong when it comes to buying things at a gift shop. So this is definitely not a large enough sample size, but I'm doing it just so I don't waste your time. Is that clear? Okay, now I go to stat, our favorite button. Then we're going to go to tests. Which test are we going to do this time? Any thought?
To the integer.
It's not, the int is for confidence intervals, by the way. And we're doing a hypothesis test. So you're right about the 2, because we have 2 samples, and then it's t-test. Okay, it's a 2-sample t-test. Okay, we have 2 samples. We're talking about means, and we don't have a population standard deviation, which you never will, by the way. So that's why it's a t-test. I hit enter. And we have data. So if it said stats, then you go to data and hit enter. L1 is list 1, which is correct, but I'm just going to show you. Type in second 1, and that gives you L1. L2 is correct for list 2. Freq 1 and 1 are good. And then we have our hypothesis now, if you remember, was a greater than. Because we want to show that people spend more money when they're given candy. So here's just something to remember in this class, because this is elementary statistics. Never say yes to pooled. So think about this. It's winter quarter in Tahoe. Do you want to jump in that pool? It's cold. Don't. So just say no to pooled. Can you remember that? So you'll never have to say yes to pooled. Okay. Then we go to calculate. And what do we see? What's the most important number here? Of all these numbers. Yeah. P is it's not 0.05, it's 0.054. So be careful about stopping at 2 decimals when you get 0.05. Does that make sense? So this is one you actually carry another decimal because it's a little bit higher than 0.05. So we're really bummed on this one. Okay, so let's go ahead and write our conclusion out. So note that how to get to 11. That's better. So P was equal to 0.054, which is greater than 0.05. If it doesn't say 0.05 is what we typically use. So then there is statistically insignificant evidence to conclude that the population mean amount of money spent if given candy is larger than the population mean amount of money spent if not given candy. Any questions on that? I want to emphasize those words population mean. Those are required in my class. Got it? So if you talk about means and you're doing a, what's your conclusion? You need to have that word population mean. Okay? Or I take off points on the final. Okay, and your project too, by the way. Any questions so far? Okay. Notice, by the way, these people, these are just groups of people that have nothing to do with each other. So this person that spent 25 is not the same person that spent $37. So let me go and do one more example before we jump to talk about the project. Okay, so here's the next question. The typical thing that a psychologist would do. Are people better listeners if they do not have use of their eyes? 12 volunteers were first given 100 words to remember. while they were looking at the person speaking. Then they were given 100 words while blindfolded. Each time the participants were asked to write down as many of the words as they could remember. The table below shows the outcome of the study. All right, so what makes this profoundly different than the last one? There's one big difference in this one. Any thoughts? In terms of the way we're going to handle the statistics. I don't see you all jumping in at once, but hopefully you can tell me. All right, if you don't know, maybe I'll mention it. Okay, the idea here, see this number 14 and the number 17, those first numbers? That's the same person. Is that clear? Because it says that every volunteer was first tried it looking and then tried it blindfolded. So we call this dependent data because we're looking at the difference between, like before, but this time one person had two answers. Any questions on that? And when you have one person or one thing have two results, that's dependent. Whereas if this 14 and 17 did not come from the same person, then it would be independent. Any questions on the difference? Okay, when you have dependent data, our H naught is going to be mu sub D, D for difference, equals 0. And H1 we're going to have mu sub D, and then I'll start thinking about it. And let's talk about what we're going to let D be. So D is going to be the difference between looking and blind. So we're going to do looking minus blind will be what D corresponds to. Any questions on this idea so far? All right. So notice, for example, we want to find out if people are better if they do not have use of their eyes. That means the blind people do better. Well, if the blind people do better, if the person does better blindfolded, that would be like this first person with 14 and 17. And notice if you take looking minus blind, you get a negative number. 14 minus 17 is negative 3. Any questions on that? Okay, that's hard for a lot of people, so I wanted to really emphasize. You can do 14 minus 17 because that is a case where blind is more than looking, better memory. So you find a case that's true, do the subtraction, and that's less than 0. Had it been greater than 0, then it's a greater than. But this is a less than 0. Any questions so far? Okay, now I'm going to go to my calculator. And let's clear what we have. And I'm going to do, how would you know what to subtract first? You get to choose, but traditionally you do L1 minus L2. So first minus second. If you just always do the same, life will be easier for you because you'll have less to remember. Does that make sense, Bishop? It turns out you can go either way, but if you go the other way, you got to remember what you did. So if you always go the same way, then you don't have to remember. Because if you just always do L1 minus L2, trust me, life is easier. So now I'm just going to enter the data. I got to clear my old data. I got to clear. There we go. And let's just typing away. 14. And then 23, 15, 37, 4, 19, 22, 37, 18, 16, and 22 again. And then L2 was 17, 25, 20, then 37, 3, 29, 24, 53, 35, 20, 19, and 22. Oh, I missed something. Let me find which one I missed. All right, let's look at it again. 14, 17, 23, 25, 15, 20, 37, 37, 4, 3, and 19, 29, 22, 24. Ah, this one. That was supposed to be 22, 24. That was supposed to be 51. Sorry about that. And then below 51 is 37, then 18, 16, and 22. Good, good. Any questions on entering the data? All right, so you'll notice that in our null hypothesis and alternative hypothesis, we just had a mu sub d, a single mean. So the way you make that happen is the following. You go second, quit, and you go second 1, that's L1, minus second 2, that's L2, and then you hit the stow button, and you go second 3. So what that does is it stores L1 minus L2 into a new variable called L3. And there's our numbers that got subtracted. Now we can go back to stat. We're going to test. And now it's just a single sample. It's a sample of differences. So I'm going to do the t-test. I have data. And our mu naught is 0. Our list was not L1, it's L3 now. So second 3. Freak is 1. And we want it to be less than. And then calculate. Any questions before I hit calculate? Okay, let's hit calculate. And what's our p-value? That's the most important thing. So what do you see? So why is m not 0? That came, I'll show you in a second. I have to leave the screen and then I'll show you. I'll answer that. But what's the p-value? Because that we need. Yeah, 0.0176. So I'm going to leave the screen and you'll see why mu naught is 0. There's your mu naught. That make sense, Pooja? Yeah. So mu naught 0 because we have a 0 there. In our class, it's always going to be 0. There are like a few very, very rare instances where you're going to have that to be something else. But in our class, it'll always be 0. Okay, so then, and this is for the, this is called the dependent sample t-test, or sometimes also it's called paired data. So note, by the way, our p-value was equal to 0.0176. So what does that tell us? So what does it tell us when the p-value is 0.0176? What's that tell you? Yeah, statistically significant evidence. So there is statistically significant evidence to conclude that the population mean, remember you gotta have those words in, and EAN, number of words, that people can remember when blindfolded is greater than when they are not blindfolded. Okay. You could also say that the population mean when they're not blindfolded is less than when they are blindfolded. Same thing. Any questions on this example here? Any questions? Okay, I do want to mention something just so you don't get surprised. There is no discussion post assignment due tomorrow. Any guess why? Because there's a reason. Yeah, you had the midterm, and I feel like I should give you a little break because you should all be tired. Does that sound right? Yeah, so I give you a little break, but you still have to do the regular chapter 10 assignment, just not a discussion post. Okay, because you still have to know chapter 10. So if you're wondering why I don't send something out on tomorrow, reminding you to post on the discussion assignment, that's because there is none this week. Then we'll go back to one next week. There'll be a new discussion assignment. Any questions at all on this last example before I talk about the project?
Yeah, I do have a question.
Sure.
So for the differences, so for the mu1, mu2, for the differences question, you're not really, I guess, going to be too specific on how it's answered. You're looking for the p-value because they could be answered either way, like whether it's greater or less, if that makes sense.
Are you looking at the 0.0176? Is that what you mean?
Yes.
And you're saying, is that big or small?
Well, I mean, like as far as like your conclusion, so you're only really looking for like how we're going to explain the p-value, right?
Well, this is not explaining the p-value. This is the conclusion.
Okay.
If I say explain the p-value, maybe I'll type that out just for fun. That's a whole different thing.
Okay.
So explain the p-value is very different. So that would be, let's write it out because you asked. And you'll see it's very different. I'll do it in a different color so you see. So that would be if the population means mean words remembered while blindfolded is the same as without the blindfold. And if we tested another, how many we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, 7 at the top. 12 people or volunteers. Then there would be a 1.76% chance that And now this came from the calculator. I know you can't see the calculator, but I can. And you'll notice that the mean difference was negative 2.2 about. I'm going to use one decimal place. Chance that, so again, negative 2.2 the population mean as a sample mean number of words while blindfolded would be at least 2.2 greater than, then let's move that up a bit, the sample mean without the blindfold. Very different, isn't it?
Yeah.
So the second one is interpreting the p-value. The first is the conclusion.
Got it.
Yeah, and we had that in chapter 9. That's why I'm not spending too much time on it now, but it's the same idea, isn't it?
Yeah.
As what we did in chapter 9. There's also interpreting the level of significance. And I don't have space for that, but it's similar to what I just wrote. The first part's exactly the same.
Okay, thank you.
Okay, but good question. Because a lot of people get confused between the conclusion and interpreting the p-value. And they're very different. Okay, any more questions before we move on to the project? Okay, so let's move to the project. Okay, so first thing I figured I'd show you how to find it. So this is, if you click home, you get popped right here. If you go to syllabus, I think is the easiest way. And you click project 2. Okay, so let me read through this and I'll talk about it. So one of the things to note is that project 2 is really all about chapter 10. So what we're doing this week. That's why today's the day to talk about the project. So that's important. Oh, you know what? Before I do that, I want to do one thing first. Sorry. Because I don't want to forget to do this, or you'll all be mad. And that is give you a secret word. And the secret word is difference. Because this chapter is about finding out if there's a difference between the two. Yeah, what is the difference greater? Is the difference negative, et cetera, et cetera. D stood for difference, remember? So the secret word for this week is difference. Okay, now we'll talk about the project. Okay, so again, I try to make it easy to find. All you have to do is go to the syllabus, click project 2. There's a few places you can do that. Okay, the purpose of project 2 is confidence intervals and hypothesis testing. That's what we've been doing the last 3 weeks. So that's what we're doing. Okay, so I don't think I wrote it in here, but it's the same as project 1, is that you need to find a client. Okay, and again, it can be fictitious, but it should just be believable. Okay, so the first thing you have to decide is what you're interested in. So step 1 is to write down your null hypothesis and your alternative hypothesis. You do that before you collect the data. Got it? Then what you do is you can plan how you're going to collect the data, but don't collect it yet. The next thing you should do is post on the Project 2 discussion forum and post what your idea is so I could look at it and I could tell you if it's going to work or not. And what I want you to post is the null hypothesis, the alternative hypothesis, and how you're going to collect your data. Any questions on that first? Okay, so that's what I want you to post, and I'll look at it and I'll let you know if it's going to work or not. The first step I forgot to mention is make sure you have partners. Okay, the same rules before. Strongly recommend to have 3 in your group, but 2 is allowed. 1 is not okay. Okay, huge penalty if you're by yourself. So you should double check to make sure your partner that if you had a project 1 partner and you want to use the person again or be together again, people, I guess, make sure they're still in the class. We have lost a few people, and that usually happens with online students. That they don't realize that this class takes a lot of time, which it does, and then they drop. But we still have a group, so make sure you check to make sure you have a partner. And if you don't, then post in the Project 2 discussion forum saying, hey, I need a partner. Okay? All right, so step 1 is do the hypothesis, is write down what is your null and alternative hypothesis. Step 2 is to write down your repercussions of a type 1 and type 2 error. Okay? Notice, by the way, this is about chapter 10, and in particular, it must be about 2 means. The main reason I do that is that for proportions, you need sample sizes like 1,000 or so, and that's just way too big to make you do that. So we're going to do means. Is that agreeable for y'all? With means, you just need over 30 for each. It could be either dependent or independent. So paired data or not, or independent, like the 2 examples I just showed you. Then, once you've decided on what your repercussions of the type 1 error and type 2 error, you decide on your level of significance. Standard is 0.05. If the damage done because of a type 1 error is worse, then you should use 0.01. If the damage is done by type 2 is worse, you should use 0.10. So please ask any questions if you have them as I go through this. Any questions so far? Okay, and by the way, when I talk about the steps, this is also the order at which you do your writing of your paper when you write it out. So again, when I say state your null alternative hypothesis, you're going to be writing a whole paragraph on why you chose that as the null alternative hypothesis. You're going to state it in symbols, and you're going to state it in words. Okay. Once you've decided on your level of significance, the next step is to collect your data. So here's what you don't want to do. Don't think that this is project 1 because it's not. The data collection should be very easy. You are welcome to collect data from the internet. That's fine. You're welcome to use convenience sampling as long as you say you use convenience sampling and talk about the issue with that. Okay? You don't have to do a survey of people. You can collect data. That's fine too. But one thing is that if you could collect the entire population easily, then that's not okay. Because then there's no reason to do a hypothesis test if you know the whole population. Any questions on that? Okay, your sample sizes have to be greater than 30. That's important. Okay. You should talk about all of this stuff in terms of, maybe your means and stuff like that, but that's a small part of the project. The emphasis of the project is a hypothesis test and the confidence interval. What you're going to want to do let me grab it. it's taking time. Here we go. Is you're going to want to use the spreadsheet. I made this for this project, so, and for other stuff too. But it's easy to use the spreadsheet if you go to the 2 VeriStats this time, not 1 VeriStats, 2 VeriStats. Here's data. Okay, but I'm going to erase this data. There's too much of it. There's going to be a bunch of data. If you copied this for your last project, then you have it. Okay, you just go to this tab. Then, depending on whether you're going to be doing a paired data, so independent or paired data, which is dependent or independent, you're going to copy your results into your paper. So you must have the spreadsheet results in your paper. That takes 10 seconds. So you're not allowed to use a calculator, you must use a spreadsheet. And again, that's a transfer requirement, that if you use a spreadsheet, then this transfers to many more places than if you use a calculator. That's why I make sure that there's a piece of the class that uses a spreadsheet. Any questions so far? Okay, so you look at the spreadsheet, and a very important number is the standard error. And that, like the standard deviation in project 1, standard error is going to be a big emphasis in the project. And because so many people have trouble with it, I created a video. It's almost 15 minutes long because there's a lot to talk about. I'm not going to say it or show it to you now, but there it is, and you can watch the video, and that explains the standard error in case you're having trouble with that. Any questions so far? Okay, so then you're going to run your hypothesis, you're going to get your p-value, you're going to write your conclusion, interpret the level of significance, interpret the p-value, but don't do it like it's a homework problem. Write a whole paragraph on it. Explain why your client cares and what it does for your client. Explain how it relates to the standard error. And just like everything else in this class, if you ever have questions, post on the Project 2 discussion board and I'll help you out. Okay? Because again, there's a lot of confusing stuff here. So this is where I can help you. Okay, the other big piece is confidence interval. So confidence interval and its interpretations. All right, so what you're going to do, it says give the reason for choosing the confidence level. Confidence level has very little to do with the significance level. So let me go back to the spreadsheet. So let's suppose you had dependent difference. Then there's a 95%. You could also choose, say, 90%. It's very easy to look and compare. And look at the pros and cons of using a 90% versus a 95% versus a 99%. You could even talk about the numbers if you want, the pros and cons. Then, based on the pros and cons, choose one, choose which is the best for your client. Okay, and then throughout, make recommendations for the client. What decisions will the client make based on this lower bound of, say, 0.95 and this upper bound of, say, 5.85. Okay, these are the made up numbers. Your project's gonna have real numbers. Any questions on that? So throughout the paper, just like project 1, you're gonna talk about how the client is gonna make a decision after seeing that number. Okay, don't do it in general, that number. So the important numbers again are the confidence interval lower, confidence interval upper, the standard error, the p-value for whatever you're doing, whether you have two-tailed, right-tailed, or left-tailed. You're only going to use one of those. And those are the main things that you're going to be talking about, and talking about what decisions your client are going to make after seeing those numbers. Okay? Any questions on that? Okay, then once you've, let me go back to this. So again, you're going to explain all about the confidence interval. You're going to run the hypothesis test. And you're going to talk about it. Notice I wrote, after looking at the p-value, is there reason to conduct a new study? When have you recently seen something like this sentence?
The midterm.
Even more recently. And Pooja, I don't think you saw it. Sorry.
When we had the p-value of 0.06.
Yeah. And 0.04 and also I don't remember the other number, 8 something or something like that. Do you remember that? That's why I did that for you, so you're ready to answer that question. And again, your p-value be whatever it is. You know, I don't know what your p-value is going to be. You don't either until it happens. So Pooja, by the way, this will be recorded. So you'll want to look at the first, 20 minutes that you missed. That make sense?
Yes.
And so that was all explained in the first bit. So that happened. And it'll be on YouTube. It usually takes me a couple hours before it actually gets all recorded and stuff. It takes time. Okay, so I want to double remind you that this confidence interval and the hypothesis test, those are the biggies. Okay, most of your paper should be on that. The rest are small stuff. Got it? So usually 3/4 are just on those two things. Okay. And then notice these are smaller these are smaller little bubbles. And what assumptions did you make? That has to do with, you're probably going to have convenience sampling or something like that. And you'll have that. You shouldn't have to assume that you have a normal distribution, because the central limit theorem will guarantee that, because your sample size will be large enough. Okay, but bias is definitely an assumption. No bias. Okay. Throughout, you should talk about why, you should convince the reader that this is important. Okay, all throughout the paper. Okay, and maybe at the very end, you can talk about how you might make it better. Okay, in other words, what other questions might you ask? Or how could you get rid of some bias, that type of stuff. That's a small discussion. All right, just like the last one, if you, and let me copy in the syllabus again to remind you. So if you email it to me by 8 a.m. the Thursday before the due date. By the way, the due date is March 15th. Okay, so you're going to need to send it to me by 8 a.m. on March 13th. And if you can do that, then I can take a look at it. I want to give you some bad news, though. Sorry, I just found out today. I'm on a hiring interview. I'm an interviewer. I'm not applying for a job. It's the opposite. We're hiring somebody. And I'm on the committee, and I'm going to be in interviews all day on the 13th and all day on the 14th. I just found out today. So if you could send me a little before that, like the, midday on the 12th, then I got a better shot of being able to get it to you earlier, because I'm going to be in 8 hours of interviews each day. I'll be very tired, as you can imagine, interviewing people. We're hiring a director of research, grant development is what we're hiring, and I'm on that committee. Happens, sorry. The other thing is the 15th. Where is it? I got it. I'm in February. Sorry about that. We're looking at March 12th, not 13th. 12th is a Thursday. So if you can send it to me by midday the 11th, that's much better. Just to let you know, March 14th is a very special day. How come? Anyone know? Here's a hint. This is a math class. Most important day of the whole year for math. Not for statistics, but for math. It's Pi Day. 314. And because it's Pi Day, I'm going to be away at a Pi Day conference. So unfortunately, I'll be online a little bit, but not too much that day. And I'm giving a talk in there, so I'm going to be pretty busy. So I won't be able to check a whole lot those few days before. So you really want to work on this early if you want my help. Sorry about that, but it's unavoidable. Things I didn't know about before the class even, before today even. Pi Day I knew about, but not the interviews. So sorry about that. So, you know, get your questions in early. Any questions at all about this project? Okay, and the submission is the same as project 1. There'll be a project 2 submission to send it through. Okay, any questions? Okay, I always try and not go too long on these webinars. It's 7:16, which is about when I like to start-ish. I like to stop, I mean. But I'll be happy to answer any questions. I think I'll go back to us. So if you have questions, this is a good time. It could be about the project. It could be about the midterm. It could be about difference between 2 means or proportions. Or it could just say good night, one or the other.
I had a question.
Sure.
Is the final cumulative?
Yes.
Okay.
Yeah, the final is cumulative. It starts from day 1 and it ends at week 11.
Okay, and are we also able to use an index card then or no?
The good news is no. That sounds bad, right?
Yeah.
The good news is, because you can use one of these guys.
Yay!
So front and back, full paper.
Okay,
Yeah.
just the front.
You could do front, you could do back.
Oh, cool. Okay.
Front and back. But you can't do a paper and an index card.
Okay, got it.
So make sure that the stuff you had on the index card for the midterm, you put on the paper. You have to rewrite it, in other words.
Okay.
I mean, I guess you can copy it, but it's better to write anyway. It's good practice. Yeah.
Okay,
So I'd let you have lots of writing.
Okay, and then for the project, we have to have 3 people, or can we have?
You don't, but let me just tell you this, is that if you have 2 people, you have to do 50% of the work, right?
True.
If you have 3 people, you have to do 33 1/3% of the work, which sounds easier.
3 people.
Yeah.
4.
So again,
5.
I don't like grade you down if you have 2, but you'll be more
Yeah.
tired.
Okay.
Do you see that?
Yeah.
So if there's only 2 of you right now, then just watch the discussion board. And if there's somebody pleading for a partner, please let them in. Sound good?
Yes.
Because otherwise you're being mean also, and there's that issue.
Yeah, I don't want to be mean.
Huh?
I don't want to be mean.
You should never be mean because there might be someone desperate to find a partner. Okay. And I don't know right now, there could be people that are quitting because the midterm is so hard. I really have no idea.
Yeah.
You know, but
Okay.
I'll check on your part and make sure that you're still in the class. We have lots.
Aw. Okay, thank you.
Okay, anything else?
No, that's it.
Okay,
Thank
well
you.
then have a good night. And for all of you watching this as an archived video, have a great night. And please post on the Q&A discussion board if you have any questions that are general about chapter 10, for example, and post on the project 2 discussion board if you have any questions about the project, or if you're looking for a partner, or if you want to propose your hypotheses. And I'll be grading your midterm tomorrow, so I hope you did well. So have a good night.